But let's first discuss factoring. Once the radical signs are removed, if a polynomial remains, then try factoring it to solve for the variable. So let's say you started with the radical equation, radical x plus 10 is equal to x plus 4. You would remove the radical and then move these terms to one side of the equation, leaving you with 0 on one side and the polynomial x squared plus 7x plus 6. And then once you factor this, you would wind up with 0 is equal to x plus 6 times x plus 1. So this is the basic flow that we're aiming for. So let's dive deeper into the details about each of these steps. If the coefficient of x squared is 1, then the polynomial can be factored if the coefficient of x is equal to the sum of the factors of c. So let's break this statement down a bit. First, we want the coefficient of x squared to be 1. If the coefficient is not 1, that doesn't necessarily mean that it can't be factored, but it makes it a lot harder to factor the polynomial. So for us, when we're going to try factoring, we want the coefficient of x squared to be 1. So that's the first good thing. And then once we see the coefficient of x squared is 1, you then want to look at the second and third term of the polynomial. And again, the polynomial can be factored if at this point the coefficient of x is equal to the sum of two of the factors of c. So when you have your resulting polynomial, you want to look at the constant and consider the factors. So what are the factors of 6? Well, 1 times 6 would give us 6. So you look at the sum of those factors. 1 plus 6 is equal to 7, which is the coefficient of x. So these are the factors that we're looking for as far as the factors of 6. If you consider the other factors, so in this case, 2 times 3 would also get us a 6. But the sum of these factors, 2 plus 3, does not equal the coefficient of x. So that is how you know it is these factors that we're looking for. Now, once you've determined which factors of c have a sum of b, we want to create the factors for the polynomial. So once the factors of c are determined, then create the factors of the polynomial by adding the variable x to each of these factors inside a pair of parentheses. So x plus 1 is one factor, and you're multiplying that times x plus the other factor, which would be 6. So this polynomial, x squared plus 7x plus 6, is equal to x plus 1 times x plus 6. Each of the factors added to x inside a pair of parentheses, and you multiply those. Once you have the factors of the polynomial, you want to set each one equal to 0 and solve for x, and this is because of the zero product rule. If a product equals 0, then one or both of the factors must be equal to 0. So as a result of this, you want to set each factor equal to 0 and solve for the variable x. So we had 0 is equal to x plus 1 times x plus 6. And the only way that two numbers equal 0 is if one of them equals 0. So either this one is 0 or this factor is 0. So you solve both for x, and then we're going to check both values. So x plus 1 is equal to 0 will give you x is equal to negative 1 as one value of x. And x plus 6 is equal to 0 would leave you with x is equal to negative 6 as the second potential value for x. So that is how you would go about solving the polynomial by factoring it. Let's take a look at a practice question from start to finish. So you would be given the question, solve for x and check the answers. Radical x plus 6 minus x is equal to 0. So how would we go about solving this? The first thing we do is we want to isolate our radical sign. So we add x to both sides. That leaves you with the square root of x plus 6 on the left side, and 0 plus x, which is x on the right side. Since the index here is 2, step 2 is you want to raise both sides of the equation to a power of 2, leaving you with x plus 6 on the left side and x squared on the right side. Since x appears more than once, we want to move these terms to the same side. So we subtract x and subtract 6 from both sides. So step 3, subtract x from both sides. And step 4, subtract 6 from both sides. X minus x is 0. 6 minus 6 is 0, leaving you with 0 on the left side. And now on the right side, we have x squared minus x minus 6. So we have our polynomial, and we have 0 on one side, which we need. If you had a constant, you want to move that over as well. So we have 0 is equal to x squared minus x minus 6. So we have a polynomial, and the coefficient of x squared is 1. So we want to consider the factors of c to see if they can equal the sum of b. The factors of negative 6, that would give you negative 1, are negative 3 and positive 2. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. So 0 is equal to x squared minus x minus 6 is equal to x minus 3 times x plus 2. So we have factored the polynomial successfully. And now step 6, you want to set each factor equal to 0. So x minus 3 is equal to 0, and x plus 2 is equal to 0. And now we solve for x. So x minus 3 is equal to 0, so we add 3 to both sides, leaving us with x is equal to 3 as one potential answer. And then our second factor, x plus 2 is equal to 0. You subtract 2 from both sides, leaving you with x is equal to negative 2 as our second potential answer. And now lastly, step 8, check the answers by plugging each number into the original inequality. So that was the square root of x plus 6 minus x is equal to 0. We first want to check negative 2 by plugging it in both places where you see x. So that gives you negative 2 plus 6, which is 4. The square root of 4 is 2. 2 minus negative 2 gives you 2 plus 2, which equals 4. And 4 is not equal to 0. So since the left side does not equal the right side, this is not a valid answer. So x does not equal negative 2. Let's test the second answer that we got, positive 3. 3 plus 6 is 9. The square root of 9 is 3. And 3 minus 3 gives you 0. Confirming the left side of the equation equals the right side of the equation when x is equal to 3. So the only correct value for x in this question is positive 3. So that is an example of a radical equation that you would solve utilizing factoring to solve for x. Let's now have you do a few practice questions. Solve for x and check the answers. Question number 1, the square root of x minus 4 plus x is equal to 4. Question number 2, the square root of 5x plus 6 minus x is equal to 2. And question number 3, the square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, the square root of x minus 4 plus x is equal to 4. So you want to isolate the first radical. You do that by step 1, subtract x from both sides. That leaves you with the square root of x minus 4 on the left side of your equation and 4 minus x on the right side. You now, step 2, want to raise both sides of the equation to a power of 2. That negates this radical sign, leaving you with x minus 4 on the left side and 4 minus x squared on the right side. And step 3 will be to use the FOIL method to expand this expression, 4 minus x squared. When we do so, 4 times 4 is 16. 4 times negative x is negative 4x. Negative x times 4 is negative 4x. Negative 4x minus 4x is negative 8x. And negative x times negative x gives you plus x squared. So now we've removed our radical sign. We want to move these terms to the same side of the equation, so we get 0 on one side. So step 4, subtract x from both sides. Negative 8x minus x is negative 9x. We have positive x squared. And then step 5, add 4 to both sides. So we have 0 on the left side. 16 plus 4 is 20 on the right side. So now we have the polynomial 0 is equal to x squared minus 9x plus 20. Our coefficient of x squared is 1. So we want to consider the factors of 20 and see if any of them have a sum of negative 9. And those factors would be negative 5 and negative 4. So step 6, when we factor the polynomial, we get x minus 5 times x minus 4. Negative 5 times negative 4 is positive 20. Negative 5 minus 4 is negative 9. So this can be factored to 0 is equal to x minus 5 times x minus 4. And we set each factor equal to 0. So x minus 5 is equal to 0. And x minus 4 is equal to 0. And now we want to solve each of these for x. X minus 5 is equal to 0. To solve for x, we add 5 to both sides, leaving us with x is equal to 5 as one potential answer. The second factor we had was x minus 4. So to solve x minus 4 is equal to 0, we add 4 to both sides, leaving us with x is equal to 4 as our second potential answer. And now step 9, we check the answers by plugging each number into the original equation. The square root of x minus 4 plus x is equal to 4. So we first plug in our first potential answer, 4, in each place where we see x. 4 minus 4 is 0. The square root of 0 is 0. So we're left with 4 is equal to 4, which confirms that x does equal 4. And now we test 5. The square root of 5 minus 4 is equal to the square root of 1, which is equal to 1. Plus x is plus 5. So 1 plus 5 is equal to 6. And since 6 does not equal 4, x does not equal 5. So the only answer to question number 1 is x is equal to 4. Question number 2, we had the square root of 5x plus 6 minus x is equal to 2. Step 1, add x to both sides, isolating the first radical, the square root of 5x plus 6. And on the right side, we have 2 plus x, which is the same as x plus 2. To remove this radical sign, we are going to raise both sides to a power of 2, leaving you with 5x plus 6 on the left side of the equation and x plus 2 squared on the right side of the equation. Then step 3, expand this expression by using the FOIL method. So x plus 2 times x plus 2 gives us x times x, which is x squared. X times 2, which is 2x. 2 times x, which is 2x. 2x and 2x combine to give you 4x. And 2 times 2, which is positive 4. So now we want to get 0 on one side of the equation. So step 4, subtract 5x from both sides. And step 5, subtract 6 from both sides. 5x minus 5x is 0. 6 minus 6 is 0. So that is how we get our desired 0 on one side. And now on the right side, 4x minus 5x is negative x. 4 minus 6 is negative 2. So we are left with the polynomial 0 is equal to x squared minus x minus 2. Now we see the coefficient of x squared is 1. So we consider factoring by thinking about the factors of negative 2. Are there factors of negative 2 that have a sum of negative 1? That would be negative 2 and positive 1. So step 6, factor the polynomial. And when you do, we get x minus 2 times x plus 1. Negative 2 times positive 1 have a product of negative 2. Negative 2 plus 1 have a sum of negative 1. So these are our factors. And now step 7, set each factor equal to 0. So x minus 2 is equal to 0 and x plus 1 is equal to 0. And now we want to solve each of these for x. So x minus 2 is equal to 0. We add 2 to both sides, giving us our first potential answer of x is equal to 2. The second factor was x plus 1. We subtract 1 from both sides, giving us our second potential answer of x is equal to negative 1. So now we want to check the answers by plugging each number into the original equation. The square root of 5x plus 6 minus x is equal to 2. So let's first plug in negative 1 in both places where we see x. 5 times negative 1 is negative 5. Negative 5 plus 6 is positive 1. We have minus negative 1, so minus a negative gives you plus. The square root of 1 is 1. 1 plus 1 is 2. And since the left side, 2, equals the right side, which is 2, that confirms that x does equal negative 1. And now the second value for x, 2. When we plug in 2 for x, we have 5 times 2, which is 10. 10 plus 6 is 16. Minus x, so minus 2. The square root of 16 is 4. 4 minus 2 is 2. Since 2 is equal to 2, that confirms that the value for x, which was 2, is correct as well. So for question number 2, both negative 1 and positive 2 are valid values for x. And now let's take a look at question number 3. The square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. So we want to isolate the first radical. So step 1, add the second radical to both sides, leaving you with the square root of 3x plus 4 on one side, and 1 plus the square root of 2x plus 1 on the right side. To get rid of this radical sign, we want to raise both sides of the equation to a power of 2, leaving us with 3x plus 4 on the left side, and 1 plus the square root of 2x plus 1 squared on the right side. And now step 3, use the FOIL method to expand this expression on the right. So 1 plus the square root of 2x plus 1 times itself, squared. So our first terms, 1 times 1 equals 1. Our outside terms, 1 times the square root of 2x plus 1 is the square root of 2x plus 1. When we do that again, 1 times the square root of 2x plus 1, we're going to add that to this one. So that gives us the square root of 2x plus 1 plus the square root of 2x plus 1. We combine those together to get 2 times the square root of 2x plus 1. And then our last term of each binomial, when we multiply the square root of 2x plus 1 times itself, we are left with 2x plus 1. So now our first radical sign is completely removed. So we want to isolate our second radical sign. 1 plus 1 is 2. So we want to subtract that 2. And then we have 2x on this side of the radical. So we want to subtract 2x from both sides as well. When we subtract 2 and 2x from both sides, we are left with 3x minus 2x, which is x. 4 minus 2, which is 2. And now we are left with just our second radical on the right side. 2 radical 2x plus 1. So step 6, raise both sides to a power of 2 so that we can remove this radical. When we do, we have x plus 2 squared. And on the right side, we have 2 radical 2x plus 1 squared. 2 squared is 4. And then any radical times itself is just the radicand. So the square root of 2x plus 1 times the square root of 2x plus 1 gives us 2x plus 1. 4 times 2x is 8x. 4 times 1 is 4. So we have x plus 2 squared is equal to 8x plus 4. And now we want to use the FOIL method to expand this expression. So we have 8x plus 4 is equal to, so we multiply the first terms, x times x is x squared. Our outside terms, x times 2 is 2x. Our inside terms, 2 times x is 2x. 2x plus 2x is 4x. And then our last terms, 2 times 2 is 4. So for steps 8 and 9, you want to subtract 8x from both sides and subtract 4 from both sides so that we can be left with 0 on one side of our equation. And now on the right side, we have x squared. 4x minus 8x is negative 4x. And 4 minus 4 is 0, so those cancel out. So we are left with the polynomial 0 is equal to x squared minus 4x. When you don't have a constant c, and you have two terms that both have x, that x can be removed from each term. So when you remove one x from these two x's, you have just x. When you remove x from negative 4x, you have just negative 4. And you put the x on the outside. So this is reverse distribution. To confirm, you just go the opposite way to make sure you got your previous terms. X times x is x squared. X times negative 4 is negative 4x. So once you factor the polynomial, you want to set each of these factors equal to 0. So x is equal to 0 is one possible value for x. And our second factor, x minus 4, we set that equal to 0 and solve for x. Add 4 to both sides. So our second potential value is x is equal to 4. And now step 13, check the answers. X is 0 and x is equal to 4 by plugging each number into the original equation. The original equation was the square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. We check 0 by plugging 0 in for x. 3 times 0 is 0, so we have the square root of 4. 2 times 0 is 0, so the second term is the square root of 1. The square root of 4 is 2. The square root of 1 is 1. So we have the first term minus the second term, which is 2 minus 1, which is equal to 1. So once we see 1 is equal to 1, and the left side equals the right side, that confirms that x is equal to 0 is a valid value for x. And then we check the second value, 4, by plugging it in for x. 3 times 4 is 12. 12 plus 4 is 16. 2 times 4 is 8. 8 plus 1 is 9. The square root of 16 is 4. The square root of 9 is 3. Leaving you with 4 minus 3, which is equal to 1. And again, since the left side equals the right side, that confirms that x does equal 4 as well.